Hello dear friends, welcome to the Crystal Clear Concepts by Sid Sir. Today we are going to understand hybridization in carbon. Our main concept is to understand what exactly happens in the hybridization of carbon at orbital level. It remains fundamental concepts in the carbon hybridization where we listen the words like Sp3 hybridization, Sp2 hybridization and Sp hybridization. But what exactly happens at the orbital level, that always remains unrevealed. So in today's show we want to reveal what exactly happens at orbital level and how exactly it involves in the bond formation. I hope you will enjoy the concept learning. Let us start. Thank you. So as we know that carbon has two orbitals in its outer shell, that is 2s and 2p orbital. S orbital has a single globular structure and p orbital has three dumbbell shaped structures. Now we need to understand first of all that what exactly happens when S is combined with p orbital, and you can see on the screen that this is S orbital, this is p orbital. So when hybridization will take place, the S will combine with the p orbital. So this is called as combined state. Now what happens? You can see this green portion and some of the S orbital will add up in the p orbital. So the globe will become larger. So the upper lobe will become larger due to the s orbital is added to the p orbital lobe, and similarly some of the portion of the s orbital will be subtracted from the p orbital, that is blue portion, and you can see that it becomes smaller lobe. So when s orbital combine with the p orbital, new hybridized orbital develops, and that is, you can see that bigger lobe and the smaller lobe. This is the shape of the hybridized orbital in the carbon hybridization. Now we will understand sp3 hybridization. You can see that this is s orbital which is spherical shape, and this is p orbitals, they are dumbbell shape. In the sp3 hybridization, one s orbital and three p orbitals combine to form sp3 hybridized orbitals, and the newly developed orbitals have shape, that is upper lobe will be larger and the lower lobe will be smaller. One more thing to notice that all the p orbitals initially are at some higher energy level, and s orbital are at lower energy level. While we can see in the sp3 hybridized orbitals, the level of energy is in between the s orbital and the p orbital. So this is kind of called sp3 hybridization in the carbon. Now we will understand how exactly these sp3 hybridized orbitals are involved in the bond formation. Let us take this as a carbon. It has 4 sp3 hybridized orbitals. So we can show them like this. This is number 1. This is number 2. Number 3. And number 4. These sp3 hybridized orbitals, when they form bond, for example with hydrogen, so hydrogen will come with the spherical s orbitals. So all these hydrogens now are forming the bond with the sp3 hybridized orbital of carbon, and therefore all the bonds are called as sigma bonds. In the other way we can show this structure by this way. This is carbon, this is one bond, sigma bond with hydrogen, this is second, this bond is coming out of the plane, so this is third, and this bond is going behind the plane, so this is fourth bond, and all the bonds are called as sigma bonds. So this is how the bond formation with the sp3 hybridized orbital happens. Now we will understand sp2 hybridization. In this case, you can see that there is a one s orbital and three p orbitals are initially available. So when sp2 hybridization happens, one s orbital and two p orbitals, they combine to each other to form newly developed sp2 hybridized orbitals, and they are in number 3. So the newly developed yellow orbitals are sp2 hybridized orbitals, and 1p orbitals remain unhybridized. When the bond formation comes in picture, all the sp2 hybridized orbitals can form sigma bond, and 1p orbital which remains unhybridized, it can form pi bond. And this is how bonding takes place in the sp2 hybridization. Such kind of hybridization are seen in alkenes, where one of the double bonds is minimum requirement between the two carbon, and it can be seen in many organic compounds available surrounding to us. Now we will understand sp hybridization. As you can see on the screen that one s orbital when comes in contact with the 3p orbitals, and suppose sp hybridization is going to happen, one s orbital and one p orbital combine to each other to form two newly developed sp hybridized orbitals. And here you can see that two yellow colored sp hybridized orbitals are present, which are formed by the combining 1s and 1p orbital. However, you can also see that 2p orbitals out of the available 3p orbitals remain unhybridized, and they both p orbitals give contribution in the formation of pi bond, while the hybridized orbitals, they give contribution in the formation of sigma bonds. And such kind of cases are seen in the alkynes, where minimum one triple bond can be seen in the organic molecules containing alkyne functional group. These are the fundamental concepts of hybridization at orbital level when carbon is involved in different kinds of hybridization: sp3, sp2 and sp. However, it is a very small concept. It is very important to understand what exactly happens at the orbital level, why shape is changed, and what energy differences are occurring during the hybridization. Alkane, alkene and alkynes are having such kind of hybridization. I hope you understand very basics of the hybridization. Thank you for watching this video. You can always suggest the topics for which the videos can be made and discuss here. Thank you for watching. We love to educate. Thank you.